Hello and welcome to today's webinar hosted by the Institution of Mechanical Engineers. Today we'll be looking at the role of air quality testing in the automotive industry and how SGS, in partnership with ASL, has pioneered an innovative new testing method for whole car filtration systems. Before we begin, I'd just like to mention that we'll be taking questions at the end of the webinar. So any questions that you do have, please submit them via the question box on your screens. You can also use this box to let us know if you're having any technical difficulties, and we'll do our best to resolve those swiftly. So our speakers today are Dr. Simon Harkis and Nish Nagar. Nish Nagar has spent a large part of his career within transportation sector, both in education as well as profession. His interests lie with the technological advancement and new innovation of automotive and aerospace sectors. Nish has transitioned his career from the automotive engineering stream to business development. He offers support and solutions that meets customer-specific requirements, removing barriers and obstacles for business continuity and achieving sustainability targets. But our first speaker today is Dr. Simon Harkis. Dr. Simon Harkis has over 14 years' experience in the filtration industry. He gained a PhD in chemistry from Durham University in the UK, and following on from technical and operational roles in the industrial filtration manufacturing, he joined SGS in August 2020. He is now responsible for SGS's Filtration Laboratory in Milton Keynes, as well as holding the position of Global Filtration Technical Committee Chair for SGS, where he oversees the technical excellence and harmonization of SGS filtration laboratories all over the world. So over to you, Simon.
Hey, hello everybody. As Fran has already mentioned, my name is Dr. Simon Harkis and I am the Global Filtration Technical Committee Chair for SGS IBR. And today I'll be taking you through a technical presentation on air quality testing in the automotive industry. So let's make a start. So first I wanted to start off with some new innovations in the filtration industry with a focus on air quality and health. So with that focus in mind, let's take a look at our room air purifying testing capabilities and what's coming around the corner in terms of new testing standards. So when we think about air purifiers, we could consider those used in meeting rooms, in lounges, in the home, in schoolrooms, or in other public places such as dental or medical offices. There are various kinds of air purifiers that can be used in all of these various situations. And at SGS IBR, we're able to test them all. So it's worth mentioning as well that here at SGS IBR, not only do we test for air purifiers, but there are a whole group of allied tests for the home air products that rely on filtration to assist with air quality and health. So things such as vacuum cleaner filters that prevent dust and other contaminants from entering the air through the cleaner or from disturbance on the surface. Also HVAC filters and humidifiers, basically anything that can cause contamination to enter the air that we breathe. We test these kind of products for various attributes such as effectiveness of cleaning, air power, and emissions. And those things are equally important, right? So if you consider how effective an air purifier is at cleaning, let's say it removes 95% of contaminants, but actually it doesn't have a huge amount of airflow, then it's not going to clean the room down. So air power is just as important as filtration efficiency, and we test all of those. And we do this to many international and national standards, including a specific one that's important to us is the Association of Home Appliance Manufacturers, or AHAM for short. Their standard for air purifiers covers the analysis of particulates in the PM1, PM2.5 and PM10 ranges. And they do that across various contaminants, the main ones being dust, pollen and cigarette smoke. So stuff that you would find around, in a lot of places. You may have heard the terminology PM before, but let me just fill you in for those who haven't. It stands for particulate matter. And the number that comes after that is the size in microns of the particle that we're interested in. So for example, PM10 means a particulate matter of a size of 10 microns and below. To put that into some sort of context, a human hair typically around 70 microns in diameter. So we're talking about very small particles that you usually can't see, and they're respirable, right? They go into your lungs, and the smaller they are, the deeper into your respiration system they go. So it's important to be aware of them and to remove them where we can. So as you can see here, we have the capability to test particulate removal right down to 0.01 microns. That's 10 nanometers, to give it another term. Or to put that again into some sort of context, it's less than 1/10,000th of the width of a human hair is what we're able to detect down to using optical particle counters or various particle detection technologies that we have in our laboratories. For those of you who are interested, and who isn't these days, coronavirus is typically around 50 to 140 nanometers. So we're able to go detect particles smaller than that and in that size range. And that's been pretty important, as you can imagine, to a lot of clients recently. So typically what our clients and the market are interested in for air purifiers is what they call a clean air delivery rate. And you'll often see that quoted on the side of these type of products on the side of the boxes, or CADR for short. But this is a good frame of reference for how powerful an air purifier is, or the size of the space it should be used for, whether it's a small room or a large hallway or anything in between. And what we're seeing more and more of these days is the request to test for allergens as well as the pollen that's in the standard AHAM test. There are other tree allergens and various cat and dust mite allergens that we're being asked to look at. And we work very closely with a company called Allergy Standards Limited on those sort of allergen tests. And you'll see a lot more about that as we go through the presentation. So it's worth being aware of a new standard that's on the horizon. It's coming out of the IEC Technical Committee. I am an expert member of all of the joint working groups that you see here on this list. And I also am a secretary of the maintenance team. And as you can see from the list of the joint working groups here, this new standard covers a lot of aspects of air purification, not just the particulate matter. We've got chemical gases, ozone, and microbes, and various other things. It's been developed in collaboration with ISO, and here at SGS IBR, we'll be hitting the ground running with this test once it's formally released. With regards to testing of allergens, there have been some significant developments in the last 12 months on creating standardized test dusts to replicate those seen in real-world situations. So a lot of standard sort of ISO classification test dusts aren't really representative of what you'd find in your carpet at home or on your upholstery. Our partners at ASL recently gave an excellent technical presentation at the Indoor Air event in Finland this year, where they showed some of the technical details on their new test dust and some of the testing that was carried out at the lab that I run here in the UK for SGS IBR. And as the market and consumers become more aware of the importance of indoor air quality, I think we'll see more and more of this type of testing and development in the future. I'm absolutely certain of that. So now we've seen some background information on air quality testing and why it's important. Let's try to apply that to the automotive space. So here are some examples of various filtration testing that's carried out by SGS IBR laboratories globally. It includes fuel and oil filters, crankcase ventilation, engine intake, contamination control, fuel water separation, as well as many others, all of which are incredibly important tests for quality and operation of different aspects of an automotive vehicle, and SGS IBR and the experts in this. But with what we've been looking at so far in this presentation in mind, let's focus in a little more on cabin air filtration. So for a long time now, the established test methods in the industry have been based around taking the main component of a cabin air filtration system, usually a pleated filter of some sort, not usually up at a high HEPA grade, but some sort of physical filter. And you test that in isolation in a test rig. And there's nothing wrong with that approach. It's been the industry standard for many years. And here at SGS IBR, we're also long established as experts in that. However, we're now looking to take that a step further. So with that in mind, let's dive into the whole car filtration testing that's been carried out at the SGS IBR lab in the UK recently in collaboration with ASL. But firstly, let me give you a quick introduction to who ASL are. So more than 20 years ago, while working as an emergency physician in a Dublin hospital, Dr. John McKeon, who's the founder of ASL, he noticed a worrying trend. He saw more and more parents were coming into the hospital complaining that their child had an allergic reaction to dust or was sensitive to chemicals contained in everyday products like textiles, bed sheets, things like that. The physicians and healthcare professionals were telling parents of kids with asthma about the importance of avoiding trigger factors. The parents love this concept because it empowers them. And if they improve their indoor environment and avoid trigger factors, then they can rely less on the physician and on medication. However, it's difficult for them to link that information to actionable insights and act on the advice the doctor or the healthcare professionals given them. So ASL invented the asthma and allergy friendly certification mark, which you can see on the top right of the screen there. They developed a set of product standards that would give consumers information about whether products meet certain criteria in the areas of indoor air quality and respiratory protection. So the certification mark can help consumers who are concerned about indoor air quality, asthma, or allergies to see immediately which products have met those standards, and then they can make informed decisions about the products they bring into their homes. So that's what Allergy Standards Limited do, and then we work in partnership with them very closely. So a little bit more about why is this important, right? So people in industrialized countries now are spending more and more time in vehicles. It's becoming more and more important to consider the air quality inside the cabins of these vehicles. Public and consumer awareness is also a driving factor in this, given recent global events. It's particularly important for sufferers of asthma and allergies. You know, people are becoming more and more aware of airborne particles and how they cause health issues. So in 2022, when a leading OEM automotive manufacturer approached ASL for testing and certification of their premium in-cabin air filter, it was tested to the usual standard in isolation within a test rig by our lab in the US, by SGS IBR US, and was found to pass the testing very successfully. However, the OEM was acutely aware that this type of testing missed out several key components of the whole cabin air filtration system. Testing the filter cartridge in isolation ignored a lot of the other contributing factors in their air system. So they were very keen to look at expanding the scope of this testing to include their full in-cabin air cleaning module, essentially the whole car, right? So this is where the collaboration between ASL and SGS IBR began on developing a new full car testing methodology. So the goals were set out right from the start and were very clear. We needed to create a test that could quantify the cleaning performance of the full car system for removal of allergen-causing compounds, then be able to compare those results back with the more standard test methods. And we needed to acquire enough data to support the certification of the system for the allergen-friendly mark that we saw earlier, and confirm that the system could perform under reasonable worst-case scenarios, so really sort of stress test the system as well. So the challenge dust we used was created using an ISO standard test dust, and that essentially acted as a carrier for the allergen-causing compounds. So we doped this test dust with 3 different types of pollen. We also tested the system under a KCl salt challenge to preload the system to test the worst-case scenario and to take a look at some initial removal efficiency performance of the filtration system. Several detection systems were used. The main one being an optical particle counter to counter system to quantify the dust and the KCl salt that the system was being challenged with. So to make sure the challenge we were hitting the filtration system with was high enough and consistent throughout the test, and also then downstream to be able to detect any contamination in the cabin of the vehicle. We placed several PTFE filter pads around several points, both upstream and downstream of the filtration system. So we could use those to capture any allergens at various points. So upstream to make sure that the allergens were present in a high enough quantity, and then also in the cabin in various areas where we knew the airflow was high and where the respirable air for a passenger was. So essentially where your head would be in the passenger seat or in the driver's seat or in the back seat. And once those allergens were captured, we would then work them up using an immunoassay to detect, the levels that were still around inside the cabin. We also placed various pieces of kit like an ozone sensor, an air ion counter, and a total volatile organic compound monitor in the cabin of the vehicle to check for any side products. Because what we don't want to do is remove all of the filtration remove all of the challenge contaminant, but turn it into something else that's equally nasty. So we put all of these monitors and sensors inside the car to make sure that wasn't happening. In terms of air handling through the filter system, this is mostly handled by the car itself. So we simply added some compensation flow upstream and applied that when necessary to overcome any back pressure caused by our test setup. But the actual airflow was controlled by the car itself. So it was representing a real world scenario. And the test environment was controlled inside a sealed chamber. You can see it there on the screen, where we controlled temperature and humidity, and we held a fairly tight tolerance band on those properties. The allergens were all handled in a correct manner to ensure that no denaturing of the active biology within the samples. So yeah, a couple of challenges that we had to overcome. As I already mentioned, we were able to compensate for any back pressure caused by our test system by using our air handling systems. So what we made sure there was essentially no pressure loss in the system. And we're also able to create a workaround for the automated software in the vehicle. It kept wanting to switch itself off before the test was complete. We were able to tweak the software to be able to overcome that. And we also created, you can see it there on the bottom right, it's a custom rapid prototype adapter. We're able to turn that around in 48 hours, and it allows us to feed directly into the intake of any car system. So this was specific for this vehicle in question, but we can easily turn that around in 48 hours for any system. So as a result of this new testing setup and protocol, we're able to find a way to get a qualitative indication of the particle removal capability of a whole car system. And we're also able to find out some potential weaknesses in filter design, such as fitting and sealing of the filters within the system. So in a normal test rig, you would always seal the filter correctly, whereas in the real world situation, you're able to test whether the actual fit and function and sealing of the actual filtration system works correctly. Any bypass of the physical filter system is very quickly detected using our particle counters, and we can help with the drive design improvements on that front. It's a very effective test for quantifying the removal of allergens, and ASL were able to make decisions about pass-fail criteria for the certification of the whole system. All auxiliary detection methods successfully quantified that no harmful levels of byproducts were created by this filtration system. So we believe that this testing is much closer to the real world situation, and we fully expect to see more OEMs taking advantage of this capability in the near future. So I think I have some time left. So what I'd like to do now is take you through some other filtration testing capabilities that we have at SGS IBR globally. So let me talk you through these. There are many applications in industries where filtration is used, and in most cases, the filtration systems are critical to the successful long-term operation of equipment and safety of people. It's vital that the filters of filtration systems are fit for purpose, and that's where we come in. We test the full spectrum of filter applications and give confidence to manufacturers, system builders, and end users that their system or equipment can be operated safely and is fit for purpose. So an example of this, in the retail products area, we regularly test room air purifiers to ensure that they provide correct amount of clean air and remove airborne particles across the critical particle sizes, as I gave more details on earlier. And as this is the air we all breathe, it's clear to see why this is important. And following a similar theme, there are many industrial processes that use oil lubrication systems, and these generate oil aerosols in the respirable particle sizes that I was discussing earlier. It's vital that these aerosols are prevented from entering the air that is breathed by workers or passers-by. And we have the capability to detect these particles and test all of these kinds of filters and filtration systems. It's important to note that our testing is technically driven. We are a technical, highly capable set of laboratories, and we generally do not carry out commodity testing. As you can see from this map, we have filtration labs in key strategic locations. Grass Lake in Michigan is our original and largest lab with the most accreditations and capabilities, including liquid filtration, established as IBR back in 1984 and acquired by SGS in 2018. IBR in the UK was established in 2005 and acquired by SGS at the same time. Here in the UK, we're primarily an air filtration lab, but we also test retail products like vacuum cleaners and air purifiers. We are the SGS European Filtration Hub. More recently established is our lab in Suzhou, China, which is rapidly expanding its capabilities and accreditations. So we have a good global footprint for our key markets. There is a long-established filtration manufacturing industry in the UK that I've worked in for over 14 years before joining SGS. I also worked in a lot of filtration businesses in Germany, France, Netherlands, Belgium, and Switzerland. So here in the UK, we're ideally placed to exploit that market. We've got some photos here of the labs. The site in Milton Keynes has 5 staff members and a 650 square meter unit. We have several individual lab rooms in our building to allow us to control the environment for various test standards and room cleanliness requirements. That includes a sealed room for the air purification equipment that we were discussing earlier. The lab in Grasslake is much larger and, like I say, includes a liquid filtration testing facility. It's just completely separate to the air filtration labs. That lab is run by Operations Director Mark Ferron, who's also available at the end of this presentation for answering questions. If you have any, specifically on the liquid filtration lab, Mark would be well placed to answer those. The lab in Suzhou is larger still in terms of floor space, with 2,500 square meters spread across 2 floors. And they're rapidly building new test rigs and capabilities, specifically in air filtration. Now here we can see the touch briefly on the ISO 17025 accreditations across the global labs. The US lab is, again, it's unique in terms of having liquid filtration accreditation, but all of the labs are covered for air purifiers, vacuum cleaners, and non-compressed air filtration. And my lab in the UK also has compressed air capability as well. So a little bit more now on other automotive, aerospace, and vehicle testing. As you can see, we cover the full spectrum of vehicle and equipment types and are accredited for ISO standards and national standards, while maintaining the flexibility and technical capability to carry out customized testing for clients in engine intake, cabin air systems, engine oil, and fuel systems. A little bit more information now on fluid and hydraulic power system filtration. So we're able to test for filtration performance in both terms of contaminant removal efficiency and flow resistance. And that includes the capability to test particulate cleanliness and carry out microscopy analysis. We can also test mechanical stresses such as pressure retention and flow pulsing, again, while maintaining the flexibility and technical capability to carry out customized testing for clients. So we're primarily a filtration lab, but on the side of that, we do carry out some mechanical testing as well, both in the automotive arena and in the consumer products arena. And you can see some filter examples here and a couple of photos from inside the Grasslake lab. There we're carrying out testing for lifetime, filtration efficiency, failure resistance. Failure resistance typically tends to be burst failure due to back pressure. So on this final slide of mine, I just wanted to emphasize that when we hear the words vehicle filtration, this covers many technologies and needs. In the past, filtration requirements have been quite simple, but now the requirements of modern vehicles expands the necessity for filtration and also adds a whole suite of testing methods and regulations, which our labs are fully aware of and fully accredited to. It can have up to 50 filters per vehicle, which seems unbelievable, but it's true. So with that, I would like to thank you for your attention, and I will pass over to my colleague, Nish Nagar, who will take you through his part of the presentation. Nish, over to you.
Simon, thank you for your presentation and introduction. Hello, everyone. I am Nish. I work as a business development manager for transport sector in SGS. I will touch upon some additional capabilities and expertise from SGS applicable to automotive sector. Next slide, please, Simon. Continuing with our focus on automotive sector, SGS have expertise in 5 different verticals for product and system testing, inspection, and validation. Now, these are spread across 5 different verticals, as you see. And these are covered under 3 core businesses of knowledge solutions, connectivity, and products, and industries and environment. The testing and qualification is covered right from the granular or compound scale for materials and components all the way to full vehicle type testing and homologation and everything in between. Next slide, please. Further, SGS are also a UCAS approved certifying body. Now, for automotive sector, we offer quality management system audits and certification like IATF, VDA, several ISO standards. This also includes training and customer specific risk management audits like FMEAs and so on. Next slide, please. So now this is quite an interesting area for automotive sector. We are experiencing a significant technical advancement in automotive industry. This is due to Internet of Things, artificial intelligence, digital factory 4.0, all contributing towards the growth of this sector, equally posing a challenge on information security. Next slide, please. The risk we have experienced are largely due to cyber attacks on automotive operations, cyber hacks carried out to disrupt the business, server targeted attacks, and theft of data. Next slide, please. Now, to overcome this challenge, German Association of Automotive Industry introduced TISAX, which is Trusted Information Security Assessment Exchange. Now, TISAX is built on the requirements of ISO 27001, which is Information System Management certification. Next slide, please. Unlike ISO 27001, TISAX is quite stringent and significantly automotive-centric assessment. And it offers several advantages as you see on the screen on my slide. Next slide, please. Including this, SGS also offers environment, social, and governance. Everything we have experienced or we have seen today or learned today from SGS, sustainability is one of the key goal and agenda for SGS. We also have a strong relevance and contribution to sustainability. Today, many organizations like SGS are working towards net zero carbon neutrality, and SGS have in fact, created a framework to help organizations to achieve this goal. Next slide, please. The framework which has been developed is towards United Nations Sustainable Development Goals agenda to eradicate poverty, unemployment, controlling the natural resources, and most importantly, climate change, as we are all experiencing today. Next slide, please. Now, within this ESG assurance solutions, what we offer is third-party evaluation and verification, optimization of your business, and eventually certification, which forms the biggest part of our business. Next slide, please. And finally, to summarize our entire presentation, we learned about SGS. We are a strong, we are big global organization with a strong local presence and with industry expertise. Simon introduced us about our filtration technology, not only to automotive, but to consumer products and also industrial application. We learned about various material component and system testing, which SGS has to offer. And we also covered the areas on sustainability and UN sustainable goal objectives, which could support your organization through collaboration and partnership with SGS. With that note, I would like to finish our presentation and open the for our audience for any questions, please. Thank you.
Great. Thank you so much, both. We do have some time now for some questions. So I'll begin by asking, what sort of size are allergy-causing particles like tree and grass pollen, and are they removed successfully by air purifiers and cabin air systems?
Sure, I'll take that one. Typically, what we find when we look at things like birch tree pollen and grass pollen is that they are around the 10 to 15 micron range in size. So although that sounds small, 1/7 the size of the width of a human hair, for us, that's pretty huge, because when we're talking about filtration systems, typically the most penetrating particle size is much smaller than that, around sort of the 0.3 micron range. So these things at 10 to 15 microns are pretty big. And what you'll generally find is that most air purifiers or filtration systems are able to handle that size fairly well. And what then becomes important is flow rate, or air power, exchange rate, if you will, for air purifiers. So the amount of times that the air in a room can pass through an air purifier, how frequently it passes through, because you're removing pollen at a high rate, but only if the air can actually pass through the air purifier. So they're small in terms of what we see looking around us all day, every day. But in reality, in terms of being able to remove them using a filtration system, they're pretty big and fairly simple to remove. So I hope that answers the question.
Okay, great. Okay, so the second question is, are filtration systems or air purifiers able to remove the coronavirus from the air?
This is one I get asked quite often, as you can probably imagine, given the state of the world, how it's been for the last couple of years. So what I would say is that, as I touched on earlier, the size of a coronavirus particle, when it's aerosolized and just floating around in the air and not in a water droplet, so the smallest it ever gets really is around 70 nanometers, which is relatively tricky to filter, but not impossible. Like I say, the most penetrating particle size is bigger than that, so around sort of 300 nanometers. Typically, it depends on the filter type. And the reason for that is larger particles are captured more easily, and you can probably imagine why, right? They're bigger, they're easy to capture. But actually, counterintuitively, much smaller particles are easier to capture as well, because they tend not to follow the airflow, because they're so small. They follow what we call Brownian motion and move around randomly in the air. So there's a higher chance that they'll stick to a filtration pad or a fiber. So actually, the size of a coronavirus is relatively, it's not easy, but it's easier than some particle sizes to capture. But the tricky part of the answer to that question is, how do we prove it? So it's relatively straightforward for us to generate particles of a similar size, let's say from salt or from an oil aerosol or even dust of the same size, and prove, that a purifier or a filtration system can remove those. So we can almost surrogate a particle of the same size, but it becomes infinitely more tricky to actually test coronavirus itself. And then what do you pick as a surrogate? What is a coronavirus? It's a bag of oil with solid spikes on the outside of it, essentially. So an oil droplet isn't really the same, neither is salt and neither is dust. But in general, the particles of that size that are represented by other challenges like oils, dusts, salts are relatively well filtered by air purifiers. So I've kind of answered the question, but not at the same time. And that's kind of the state of play in the whole industry, right? Which is, we know that a good air purifier or a good filtration system will remove particles of that size, but there are very few, if any, labs that are able to test the actual live virus. That said, there is a bacterial filtration testing lab as part of SGS IBR in the US that can use biological surrogates, so bacteria of a similar size. But again, it's a surrogate. It wouldn't actually be the live coronavirus. And then you've got the question of, is the filter then safe to handle when you've got live virus captured on it? So it's a tricky one to answer, but I hope I've at least given some information so people can be aware of the challenges and what's involved when we look at those sort of questions.
Absolutely. Okay, so the next question has from our audience has a number of questions within a question. So Simon, I don't know if you want to stop sharing your screen so you can see it as well, because I will read it out, but it might be better if you could see it as well. So what type of filter was fitted to the car? Did the vehicle ATC switch between the fresh and recirculated air, or was it forced to use full fresh air? Have those tests been performed for recirculated air as pollutants and dust? And dust can come into the cabin by opening doors, etc.
Yeah, that's a good set of questions. So let me try and tackle them one at a time. So the filtration system, it was a pleated filter. Looking at the filtration efficiency that we saw during the test, it's not a high-grade HEPA filter. But there's also other components within there, right? So I'm not sure I'm at liberty to say who the vehicle belonged to or what the technologies were, but there were, pre-filtration baffle plates, so there are ionizers in there and various other technologies, all that contributed to the full filtration system. And we ran the car in automated mode, but with fresh air. What we didn't want to do really was create a sort of a sealed environment, although it's not a sealed environment, as the question asked, the questioner implied as well. It's not a sealed environment. We couldn't create one in a car anyway. But we pulled directly from the intake and used fresh air. The reason for that is because we wanted a consistent challenge on the filter, and we were controlling the challenge directly into the filtration system. Was there another part of the question? Sorry, I think there was a third part I forgot.
Yeah, so if you did want to see it, Simon, it is in the priority inbox. So do take a look. But there was a second part of the question and a third part of the question. So you may want to take a look. But the third part of the question was, have those tests been performed for recirculated air as pollutants and dust can come into the cabin by opening doors?
Right, so not at this point. So this testing was on our side was driven by the client in this case, which was ASL, who wanted to gather enough information to be able to certify for their allergy standard certification. So we didn't try recirculated air. And had I had the car on site for longer, I probably would have done that out of curiosity. But no, not on this occasion.
Okay, perfect. Okay, so we'll move on to the next question. So the next question is, how did the test procedures allow for vibration from the device?
Is this for the car test, right?
I would assume so. There's no further information.
So we didn't. We were trying to test under worst case scenario, right? And that includes any vibrations that come with the running of the car. But what I would say was that this was a hybrid vehicle that we tested, and the internal combustion engine was not running. So there is an argument to say that in order to replicate full real world situation, the car should be driving around, right? But that brings all sorts of additional complications and logistics issues that we would struggle to overcome, especially if the vehicle's moving around and we're trying to have particle counters plugged in and all of the bits of equipment that we were using. So no, we didn't compensate for vibration, but the ICE wasn't running, so there wasn't any need to really.
Okay, no problem. Okay, so the next question is, what type of testing do you perform for the railway industry and specifically for cabin saloon air quality? Is this done in line with independent parties in the industry, and does it apply to all types of fleets, electric, diesel, hybrid?
Hey, Mark, are you on the line?
I am.
Would you be okay fielding that one?
Yeah, I would say the closest would probably be if we're getting into the actual powertrain, if you will, for the rail, I have not tested. I'm sure we have in the past, and they followed similar test capabilities and/or methods. And then if we moved into the cabin of the actual locomotive, we've tested filtration for those, as well as those have evolved through time, AC systems and so forth. But at least in our tenure here, we haven't tested anything specific to the rail, but I do believe they follow very similar methods, and we would have that test capability as well. Hopefully that answers it.
Okay, no problem. Okay, so the next question is, what type of filters are used for air purifiers designed for COVID, and why?
So, based on what I said earlier, a lot of air purifiers designed for COVID contain HEPA filters, just because of the particle sizes involved. It makes sense. But also, people look at UV light technologies and ionizing technologies, and even activated carbon. There's no real sort of one hat fits all here. People try various different things, and like I said earlier on, it's so difficult to test directly for COVID. So people are kind of making assumptions or are using existing knowledge and technologies to apply to the particle size as much as anything else. Or the UV is in terms of denature the thing instead of actually removing it. So there's various people taking various approaches. Sorry, I realize that's not really a solid answer on that one, but that's just the way the industry is. It's people are trying all sorts of different techniques.
Okay, no problem. Okay, so the next question is, are there any standards for air quality in vehicles? Is a unified test protocol assessing air quality and pollutant efficiency?
There are national ones, I believe, and it really depends on legislation. So there are standards for how you test cabin air filters and how you test air quality in vehicles, but whether you need to apply that to your local legislation really depends on the country that you're in. The guys in Mark's lab in the US test a lot of cabin air filters for air quality that use a lot of national standards for that. There are definitely plenty out there, for sure, but a lot of them are national based.
Okay, I believe that is all the questions, and so we will probably wrap up there. So I'd like to thank you again for speaking today. We really appreciate it, and for all those listening at home. If you do have any further questions for our presenters, you can contact them via email or LinkedIn. They were more than happy to answer any further questions for you. But that's all for today, so thank you so much.
Very welcome. Thank you. Take care, everybody.
Yeah, thank you.
Thank you, everyone.
Bye-bye.